All right, moving right on to chapter 9, section 2, we're going to talk about naming and writing the formulas for ionic compounds. Antoine Laurent Lavoisier was a French chemist. He determined the composition of many compounds and found that it was actually becoming impossible to memorize all the unrelated names of the compounds. So he worked with other chemists to develop a system method for naming chemical compounds. So in order to write a formula for a binary ionic compound, first of all, what's a binary compound? It's composed of two elements. A binary compound can be ionic compounds or molecular compounds. And if you know the name of a binary ionic compound, you can write the formula. Write each ion with the symbol and the charge. Always put the cation first and then the anion. Crisscross and reduce the charge numbers and not the signs. Write the numbers as subscripts and do not write any ones. So let's go through an example. Let's write the formula for the compound containing magnesium and chlorine. Magnesium has a 2 positive charge, chlorine has a 1 - charge. Take the sum of the charges, crisscross them to get MgCl2. So does that make sense? We've crisscrossed the charges, so we put this 2 positive charge by the Cl and this 1 charge by the Mg, so it disappears. So there's magnesium chloride. And here we can see how magnesium chloride is formed with the magnesium and 2 chlorine, and how the charges come together to share those valence electrons. Why does this work? You can see that shown because they now have an octet, a valence electron completely filled shell with 8 electrons. Example number 2, write the formula for the compound containing barium and oxygen. Barium has a 2+ charge, oxygen has a 2- charge. Crisscross the superscripts, turn them into subscripts, and we get BaO because the 2 down and 2 down, they'll cancel each other out. So barium oxide. Since the charge of the cation and the anion are the same, you can reduce them to the lowest whole number, which is 1. That's why they disappeared. If you know the formula for a binary ionic compound, you can then write its name. Make sure the compound contains a monatomic metallic cation and a monatomic non-metallic anion, and then name the cation first, followed by the anion. So what is the name of the following ionic compound? LiBr. We have Li positive, Br negative, that's the lithium bromide, lithium bromide. And we have to put the charges because we always want to make sure we name the cation first, lithium bromide. Remember that the cation name stays the same and the anion name will end in IDE. What is the name of the following ionic compound? AlCl3. We have aluminum, that's your cation, and then chlorine is the anion. So it's aluminum chloride because we end the anion with IED. Remember, some transition metals have multiple charges, so Roman numerals are used to determine the charge of the cation. So we have CuO, we have oxygen with a 2 negative charge and copper with a 2 positive charge because we can see that they've canceled out and been reduced to their lowest whole number ratio. So we have copper. We always want to put the parentheses, the Roman numeral 2, to identify the charge of that cation, and oxide ending in IDE. Writing formulas for compounds with polyatomic ions is the same as an ionic formula. Never change the polyatomic ion, and if more than one polyatomic ion is needed, put the ion in parentheses followed by a subscript. So let's write the formula for a compound containing ammonium and chlorine. So ammonium we know is NH4 positive, and chlorine is Cl1 negative. Remember to crisscross the charges. So we'll get NH4Cl. So we're crisscrossing the superscript charges and they cancel each other out because they're both just 1. Let's do that another example. A formula for the compound containing lithium and carbonate. So carbonate is CO3 with a 2 positive charge. Lithium has its 1 positive charge. We're going to crisscross the superscripts. The CO3 does not change at all. We get Li2CO3. Example number 7, a compound containing calcium and hydroxide. There's calcium and there's hydroxide. Let's crisscross the charges. we'll get calcium. And because this 2 plus is applying to the hydroxide, we have to put the whole hydroxide, the OH in parentheses, and then put the 2 as the subscript outside of those parentheses. Naming compounds with polyatomic ions is the same as an ionic formula. Name the cation, name the anion, and let's go through an example. What is the name of the following ionic compound? NaClO. We know that's sodium. ClO, what was that again? Hypochlorite. So some of these you have to kind of remember and memorize. Hypochlorite is ClO. Example 9, what is the name of the following ionic compound? NH42C2O4. We know that NH4 is the cation and the C2O4 is the anion with the 2 negative charge. And we know those are the charges because when we go backwards, we can crisscross, and we know that this 2 would go up to the C2O4. I remember that NH4 is ammonium. What is C2O4? That's oxalate. Again, something you might just have to remember and memorize. What's the name of the following ionic compound? FaClO3. We have iron with a 3 positive charge because we crisscross these charges. ClO3 is that, just a negative charge. I know that's iron. We have to add in the Roman numerals because it's 3 chlorate, ClO3. And that takes us through section 2. Have a great week, everybody. Thanks for listening.